system here. Yes, my name is Stefan Gruell. I'm joining from Austria, Vienna. And I would like to introduce you within the next 15 to 20 minutes to how we are using blockchain for the mining, or actually for the metal industry. Let me start off with one thought. So the Internet of Things will not only dramatically change the way we look at manufacturing, but also the world of materials, such as of steel, which is also my personal background. I joined the steel industry almost 2 decades ago, and was a managing director of one of the leading European steel distribution companies that in the late 80s enlarged its activities into the region of Central and Eastern Europe. So basically what is nowadays Central Europe. For those of you who are not so familiar with the steel industry, let me give you a short introduction. So steel is not only the key material to many of the industrial sectors in Europe, and I would say backbone for the globe, in general, backbone for development globally, but also plays a very important role in our everyday life. Did you know that each of us in Europe consumes almost 1 kilogram of steel per day? That is surprising, but when you think about it, I mean, we all use public transport, we all work and live in buildings that are also contain steel materials. But there's another resource that is becoming far more important, which is data. And 3 years ago, this article just blew my mind. And ever since then, I was kept with the question of how to actually tap the value of data for the steel and metal industry. I started my journey doing some research on what's actually driving the metal processing industries right now. So basically my former customers, which are companies from the mechanical engineering, machine building, and steel construction sector. And what I've learned is that the #1 topic there at the moment is automatization and connecting equipment, connecting machinery in order to enable smart manufacturing. And there are studies that say that in only 5 years from now, there will be probably 10 times more machines connected to the internet than there are humans on the planet. So the question for me was that if we are now connecting the machines to the internet, where steel is being processed, so what about the materials that are being processed on these machines? How are they being able to, how can we address them in a digital way? Yeah. And today we provide the information, the quality information regarding metallurgical products and steel, basically on documents by so-called mandatory inspection certificates. So that's paper. Yeah? That's paper that's being handed over together with each shipment of materials. And in these papers, parties or steel producers basically certify the compliance with relevant standards, but also these papers carry important material properties and all the relevant test results. And when I did my research, I just started to understand what numbers we are talking about. Yeah, so only in Europe, it's around 100 million certificates that are being created, exchanged, and stored every day. And of course, with a huge disadvantage because all that data still is not machine readable. And this is exactly what we are solving with SteelBot-Smart, our company. So we provide the physical material a digital identity that travels with the physical metal, so that companies can replace basically these paper certificates with traceable, tamper-proof digital records using the blockchain. In order that this data is then maintains to be available, for instance, to be used for smart manufacturing, but also in future to assess carbon emissions. And here the value is not only to digitize the paper-heavy process that I illustrated before, but also to enable entirely new business models that are built around the idea of the combination of quality data with a digital identity. So at the end of the day, we could say a digitally enriched material or a digital asset. The way we approach this topic from the technical side was basically in 3 steps. So first of all, we had to completely rethink the architecture of how this data is actually kept. Yeah. We had to think of it as a shared data layer that serves as the industry's single source of truth, because so far each party keeps its own data in its own silos. And the target, of course, is to make this data available in a decentralized network where each party first maintains full control and ownership of the data, but the data can be also shared in a trustworthy manner across company boundaries in a peer-to-peer way. The second thing we had to change is the way this data is captured, recorded, and stored at the end of the day. So what we developed technology where at each step of production we can capture the processing data, we can capture the testing data, we can keep it in a digital format, using the blockchain to ensure tamper-proof recordings, but still meeting document standards. And at the end of the day, what is also important, to find a way to support various tagging technologies, because we also need to identify the physical product in order to keep the connection with the digital twin. And here we're using technology of our co-investor, an Austrian-based company called Riddle & Code, that specializes in creating trustworthy connections between the physical world and the digital world. And this is technology that has been used already in a number of other projects and use cases in other industries, like the banking industry, like the automotive industry, and the telecommunication. The third step that we had to think of is we had to come up with a plan of how to that could actually work to migrate an industry like the steel industry, which is a very big and very complex and globally fragmented industry. And the idea here is that such a migration can only work in a number of steps. So we started off as the status quo that I mentioned before, which is paper. We developed a very easy, let's say, staging product that enables to, provide the data not in a PDF format, but in a JSON format that we hash on the blockchain. So that brings one immediate advantage. So the data is machine readable. And the second step is then, of course, to provide the data in the form of a digital asset. So at that stage, we have to really tokenize steel. And the third step will be that we also have to secure basically the source of the data. This is where the machine identities and the secure elements that I've showed before come into place. But I don't want to talk too much about the technology concepts. I would rather like to show you how that could actually work and how that could actually look from a user point of view. So I will introduce you to one of our demo systems. So here we are in a role of a steel factory, as you can see. And let me just start this presentation. So in a steel factory, you have a laboratory, you have basically, you can provide additional inspections to the physical material. You have a section where you can see the certificates that you have issued, and you have a section where you see the goods that you've issued. So what we do is that with each, let's say, when we produce physical steel, we get all the quality data of the material. So basically, that's the chemical composition that is provided with the melting of the material, and we provide this information to our blockchain solution. And at this moment, we create a digital asset. Yeah, we create at that example, it was 124 tons of steel with a dedicated chemical composition. You can see the transaction on the blockchain. And at that moment, we have created digital metal, so to say. Yeah. In the next section, I can show you that we can add any additional information to this digital asset. So in that example, I will add a certain carbon footprint to it that is then connected to this batch of material. Once the material is being created, the next step is to sell the material. Yeah. So here we are moving from the steel factory to, we're staying in the steel factory, and we basically go to the goods issued section. And if we sell material, we basically record the data of delivery nodes. So in the delivery nodes, we understand who is the customer, what is the batch of material that has been sold. Yeah. So we load one of our delivery nodes to our system, which is being done right now. And what happens here is that we split the digital asset. Yeah. So part of it stays within the steel factory, and another part, in that case 12 tons, are moved to the customer. Yeah. You can see again the transaction on the blockchain. Yeah. And all the metadata, like all the quality data that is connected to the original batch, is now used in the certificate. So now we can see that in the certificates issued, we have provided a certificate for the customer that contains all these material properties and quality information. So, yeah, and here you can also see in the goods issued section. So this way now we move to the customer, and in the goods received, certificates received section, now you can see that he has received a quality certificate related to that batch of materials. Also with this dedicated carbon footprint that we have added before. So this is how we track quality data along the supply chain. And the drivers that we see for such a solution are basically three main drivers. So first of all, it's the topic of traceability. So we have more complex product designs, we have more complex technologies, we have a globally fragmented supply chain. And that means that there is rising awareness of safety, and that means also that the standards for traceability are continuously increasing. You have on this picture, you see a bridge, and for such a bridge, you have for each nut, for each bolt, basically you have to provide full traceability of the material back to the source. The second driver is digitalization. We already talked about it before. I would say it's more adaptive process control. So the idea is that with these digitally enriched materials, they can connect to machines. These materials can mandate machines actually for optimized processing setup during manufacturing. And the third topic is decarbonization. Steel and metals are often recycling champions, but they have a carbon problem. The European steel producers are committed towards a decarbonized future. So by 2050, steel, what they want to achieve is actually a decarbonized production of steel and metals. And that, of course, means that this development will have to be supported by political framework conditions that ensure a level playing field for the European producers. So what is being discussed is initiatives like the carbon border adjustment mechanisms to avoid carbon leakage. And that, at the end of the day, means that what we need is a trustworthy assessment based on what's actually sustainable produced steel and metal and what's not. And this assessment base you don't need on a factory level, but you need it on a batch level. Because besides governments, there's also more and more industries industry-leading business organizations that are driving the need for more transparency regarding carbon emissions. So in that example, you see that the automotive industry is no longer only looking towards the emissions in the to the exhaust emissions of their car fleet, but they would also like to understand what is the carbon footprint of all the materials and parts that are being used in a vehicle. Yeah. So the question of traceability is no longer one of just raw materials, but it's one of the entire chain. It's one of the entire supply chain, and this is also one of the use cases and pilot projects that we are working on. So we are tracking for an automotive supplier quality data and carbon emissions. So from the raw material up to the various processing stages, up to the part that is then being used in a vehicle. So what I think is important, and also what is especially important for companies out from the mining space, is that if they are working on projects to make their sourcing and production more transparent towards sustainability, is that to integrate these initiatives and consortia also with other parties that are more further down the supply chain. So as the example that I have showed you before, because what I've shown you before is that we are focusing on the downstream processes, starting from the smelter, basically from the steel production plant, which is illustrated here on the right side of the slide. But of course, we would like to invite companies from the mining space to also use our technologies and solutions, or to connect ongoing projects, because at the end of the day, if we make these different projects and consortia interoperable to each other, we can achieve the mission. So at the end of my presentation, I want to leave you with one more thought. The complexity of the steel industry, and actually the lack of data processing standards, of course, also creates increasing opportunities for fraud and forgery. And today, with the use of blockchain technology, this can be avoided. So I hope I gave you a short insight now of what we are building and why we are building it. We are convinced that we will change the industry, and there is a pain, we have a solution, and we have the technology to make this change happen. Thank you very much.
Thanks a lot, Stefan. That's great. And thanks for showing us the inside workings of the blockchain, because it can be very scary when you don't actually see what it looks like, which is just like, just a very simple text, really. It is indeed a database, albeit distributed, but you don't need a spaceship to run a blockchain. So yeah. I think that's great. Thank you very much. Really appreciate you sharing your expertise. And indeed, I think mining companies can learn from your solution. So I hope we'll stay in touch. Okay. And I'm very glad to introduce our next speaker, my fellow Canadian, Nathan.